in this problem, we're given a cubic polynomial where we don't know any of the coefficients. So we've got unknowns a, b, c, and d. Okay, but we are given some points that our polynomial goes through. We're told that f at -2 is -41, f at 0 is -1, f at 2 is 19, and f at 4 is 115. So when we look at this polynomial, f of x is ax cubed plus bx squared plus cx plus d, it probably doesn't really remind you of a linear equation. Let's see though what happens when we evaluate at a point. So we're going to look at f of -2 and evaluate here. We get a times -2 cubed plus b times -2 squared plus c times -2 plus d. And when we actually evaluate this, what does it give us? We've got -8a plus 4b minus 2c plus d. And that's equal to, we know what the value of the function is supposed to be. It's supposed to be equal to -41. And notice that when we plug in our input, we actually arrive at this linear equation because we have these unknowns a, b, c, and d. They all appear without any powers. And if we repeat this process at the points that were given at 0, at 2, at 4, we actually come up with a system of equations. So this -8 is -2 cubed. 0 cubed is 0, so that's why we don't see any a term in the second equation. Here, the 2 cubed becomes 8, so we get 8a. And then 4 cubed gives us 64a. So we see here that figuring out these unknown coefficients corresponds to solving this equation, or the system where we have 4 equations and 4 unknowns. When we are in the situation where we have 4 equations and 4 unknowns, we really don't want to do it by hand unless we can do some simplifications. And looking this over, you may see some really good simplifications. So I encourage you to try it, try your hand at this and see it. Maybe you can reduce the number of unknowns that we have here. But to demonstrate what this looks like, let me show you how we would put this into Sage. Okay, so we're just going to form our matrix. We have 4 equations, so we're going to have 4 rows. We have 4 unknowns and an augment, so we're going to have 5 columns. And we're going to write out all of our entries using square brackets. Okay, so we get -8, 4, -2, 1, -41. We get 0a, 0b, 0 c's, 1d, and this is equal to -1. So that's one simplification. You might have gotten rid of all of your d's. We see 8 a's, 4 b's, 2 c's, 1 d is equal to 19, and 64 a's, 16 b's, 4 c's, 1 d is equal to 115. Okay. So this we've told Sage what our matrix should be. Let's try printing it. Well, we can. Why don't we just go straight to our reduced row echelon form? This will tell us our solutions. Okay, and we see that we have this reduced row echelon form. Let me just copy it over so we can see it a little bit better. Okay. So what have we got? Notice that this is our augment. So we have our augment column here. I'll oops. We have our augment column here with values 2, -5/2, 7, and -1. And then to the left of that, notice we've got this identity matrix. So we can read this off again. It tells us that A is equal to 2, and that B is equal to -5/2, and C is equal to 7, and D is equal to -1. Okay, and so we're actually able to write down our equation without even breaking a sweat. So our cubic that we were worried about finding is going to be equal to 2x cubed minus 5/2 x squared plus 7x minus 1. Okay, and so Sage is really powerful because often we'll have big systems that we want solutions to do, but the computations by hand can be kind of error prone, especially when we have something like more than three rows to deal with. And so Sage is a good tool for doing those computations for us, so we don't need to think about it. Cool.